Hello, knowledge seekers. Let's start our AI journey. Uh, so, let's first understand what is the roadmap to learn the AI, generative AI, agentic AI, and what are the three steps in which we can uh, learn and grow. So, first, let's understand the path. So, the path is to understand what are the foundational LLM skills required. So, one of the skills is understanding the basics of the LLM fundamentals. What is the prompt engineering? In prompt engineering, write a good prompt. There are 6 ingredients: persona, task, tone, exemplar, format, context. Then to build an agentic AI solution, workflow solutions, chatbots, we need to provide the knowledge base. So to implement, provide the context, we use retrieval augmented generation. So to know or implement retrieval augmented generation, we need to know what is chunking, and from those chunking, how to create vector embeddings and store in vector database. Then after the solution is built, the solution needs to be optimized and safe. It should be able to give the desired output in the shortest time. Then whether the input received is ethical and as per governance or not, we need to use guardrails. And similarly, while sharing the output, whether it's in the right tone as given in the prompt or not. So we need to use guardrails, and there are other ways in which ethics and governance can be monitored. So the very first step to start learning is to understand, to take the courses on different online options available, YouTube, Coursera, and so on. Then build the solutions. The most common tools libraries are available in Python, LangChain, LangGraph, Langsmith, Llama Index, Boto 3 for Amazon, OpenAI, LangGraph, the lighter version of the LangGraph and LangChain. Then attend the meetups and conferences to network with people having similar skills, and on YouTube also there are different AI groups available where one can watch the videos of the past conferences. So let's dive deeper and understand. So to learn generative AI, there are 3 layers: the interface layer, engineering layer, and the governance layer. So let's understand what's the interface layer, where we need to learn large language model, prompt engineering, building agentic AI solutions, use of RAG, and governance in the form of guardrails and other tools. So in a older way of solutioning, it was linear model where we give the input, we do the processing, provide the business logic, and get the output. So in the generative AI and the agentic solutions, it can be implemented for workflows, content creation, coding, rapid data analysis, intelligent automation. So agentic AI solutions can be built for security enhancements, collaboration, personalization, problem solving, content creation, accelerated coding, rapid data analysis, intelligent automation, and cloud integration. So there are tools like GitHub Copilot, Claude, and Cursor to use for coding. So what is the interface layer? So large language fundamentals. So in large language models, how they are built, what are the different components of large language models, the input, the encoding layer, the decoding layer, and finally getting the output which predicts the next words. So just if you ask a question and you get it predicts the words is not enough for building utilizing the large language model, so that we have the agentic workflows. Prompt engineering, as I mentioned, it has 6 ingredients to get the desired outcome from the agentic creating agents and from the language models. So whether we build agentic AI solutions or as a normal user use ChatGPT, Google Gemini, Perplexity, we still need to have a good prompt engineering skills. Multimodal AI. So we can combine our input prompt which is a mix of text, voice, and image to get the desired outcome. So the next layer is retrieval augmented generation. So to provide a knowledge base for any solution, a corpus which is a collection of documents, we need to chunk it. So the chunking is like dividing the document based on paragraph or the context or the fixed size with overlap, and then create vector embeddings. So those vector embeddings are nothing but the mathematical representation of the input text into create a vector. So like if you use OpenAI text embedding model which takes an input of about 8,000 tokens and creates a vector embedding of 1536 dimensions. The third layer is the agents. So when we create agents, the whatever input agent gets needs to be guardrailed, and for mitigating the hallucination before sharing the output, guardrail can be used to check the tone and the output generated. So what are large language models? So large language models uses transformer technology to generate words. So based on the input token, it will look into the knowledge which it has been trained on. There are models which are trained on 20 billion, 50 billion parameters, and up to 1000 billion parameters too. For average 95% of day-to-day work, models support with 20 to 50 billion parameters are good enough. Multimodal AI is the combination of text, voice, and image to generate the output. So prompt engineering. So a simple prompt we can write is write a code for a Python snake game. To make it a more focused and get the desired output based on our need, engineered prompt can be done. So it should have, you can say you are a senior Python developer to create a snake game using Pygame library. It should include comments, handle edge cases for wall collision, and it should give the output only in the Python code and without any additional explanations. So what are vector embeddings and chunking? As I mentioned earlier, chunking is the way of dividing data in a documents for a corpus for which the solution is built. So chunking techniques are fixed size chunking with overlap, context-based chunking, and so on. So in case we study vectors in mathematics, so in the vector embedding, based on what kind of language it is, like it supports word, subword, tokenization. So there are some languages which does not support subword tokens. So considering to get a optimized output for vector embeddings, every model build company has specialized models for generating vector embeddings and also converting it back to the text. So whenever user asks any question, the question is converted to a vector embedding, and very with the based on cosine similarity keyword search techniques in the existing vector database. Similar vectors are looked for, and the top 5 10 results are considered to provide the output, contextual based output to the user. So those vector embeddings along with the user questions are shared with the large language model to get the response, which is then filtered using guardrails before sharing with the end user. So how does a end-to-end retrieval augmented generation solutions looks like? In a retrieval augmented solution, a user asks a question. That question is given to an agent, and that agent will look for the information in the vector database based on the question asked, and once that answer is details are received along with the question, the input is given to the large language model to get the accurate response, and that response is filtered using guardrail before sharing with the user. So one way of avoiding hallucination is using the knowledge base. The other way is like based on specialized solutioning for life science or a healthcare or coding. The generalized base models are fine-tuned to get the focused output using specialized models. To build the specialized models, we need to have understanding of what large language models are. So to build agentic workflows, chatbots, providing agentic solution like booking a flight or getting the answer, how much luggage you can carry, what reminders on the travel date, and also using agents to not only book the flights but along with that also book the hotel and the rented car or a taxi. The agentic workflow can also be built to like once you are at the airport and your flight gets cancelled due to certain reasons, it should be immediately able to reschedule it and replan it, so cancel the existing hotel bookings, car rentals, and book it for the future date. So all such solutions can be built. So if to build such solutions based on the human input, the manager agents takes the input and it parallelly runs different agents, planner, coder, reviewer, and finally create the response and share it with the human. So for ethical AI solutioning, governance, and also to have safety and security, the 3 pillars of the trustworthy AI are guardrails, ethics and governance, and hallucination mitigation. So they're like NVIDIA Nemo guardrail is one of the guardrail solutions. So when we build agentic workflow solutions, one of your agents could be a guardrail for monitoring the input, then another guardrail agent for filtering the output. So let's summarize it back. So as we saw in the first slide, to learn, start learning the from any course online or YouTube channels where a lot of content is available. Practice prompt engineering with the help of tools like ChatGPT, Meta AI in WhatsApp. Like if you are doing going for a walk just every day based on your subject of interest, start asking questions using the prompt engineering skills. Then the next stage is build the solutions. There's a Spring AI library in Java. There are LangChain, LangGraph, Langsmith, and other libraries, Llama Index, Boto3 on to build the solutions. You can subscribe to Azure AI Foundry or Amazon Bedrock or other free other tools available. Then to for build to build a more sophisticated solutions, how others are doing it, network with other professionals by attending the meetups or following their channels on YouTube. Like there's a Dallas AI, San Francisco AI, and different YouTube channels worldwide. So the path it helps is like enhancing our skills is like one A is like whatever skills we are working on, we need to have a AI skill. Earlier we had Windows desktop implementation skills, then the browser, all the online applications, everything is browser based. Then we have mobiles with smartphones, then we have big data, and now we have AI, which is one required component in whatever solutions we build. So this is how the roadmap is, and we can learn our AI skills to grow, to build either we are a jack of all, where we need to know all the skills as a program manager, as a solution architect, or we master Gen AI skills to build as a developer or as a technical architect to build the solutions. So here I have some quiz at the end of this. You can pause the videos and go through the quiz and see how much you have learnt in this video. So, which of the following describes the process of combining information retrieval from external data source with the generative capabilities of the large language model? Next question, in generative AI, what is the primary purpose of hallucination mitigation? So at the end of this question, hints are given and you can guess the answers, and at the end you can calculate how much you have gained from the knowledge. If required, revisit to see the video. When data is represented as vectors in an n-dimensional space to enable semantic search, which concept is being applied? Which Gen AI skill involves designing AI agents to perform tasks and process autonomously? What is the primary role of guardrails in the development of Gen AI applications? If an LLM has a limited context window, which technique is used to manage and break down data into smaller digestible pieces? Next question, which of the following is considered a Gen AI fundamental that tech professionals should understand? What is the focus of prompt engineering in the context of working with large language models? Adapting a pre-trained LLM for a specific task or domain is known as? And finally, what does multimodal AI allow a system to do? I hope this will help you to make a kickstart on learning Gen AI. Thank you. Please write in comments and I will make sure to respond